Okay, again, two-dimensional problems, our second practice problem from the horizontal launch. I want to remind you, if you have not solved these problems, go back, try to solve them, then watch the video. If you're having any trouble with how to set things up, you need to send me an email. But you need to work through these things before you can just start copying down problems. It will not help you in the long run. All right, we're going to go ahead and start working on this one. So I'll read along. A diver runs horizontally with a speed of 1.20 meters per second off a platform that is 10 meters above the water. Then it says, what is his speed just before striking the water? We absolutely know that that will not be 0. If you don't believe me, smack your hand on the table, preferably without throwing your mouse on the floor. And the sting in your hand reminds you that you are not hitting that table with 0 velocity. He is not hitting that water with 0 velocity or 0 speed. If anybody's ever done a belly flop, you also know that to be true because it hurts very much. All right, so let's start by diagramming the situation I have here. If I can get my pen back. There it is. All right, so I have an object. It's 10 meters above the surface of the water. I'm going to launch horizontally. And of course it's going to have this sort of curved trajectory. And we're looking for this velocity, and actually it's a speed, so it's really the magnitude of Vf that I'm looking for. Okay? Remember, this does not mean absolute value, it means the magnitude of the velocity. And the velocity will be tangent to the path at that point. Alright, so let's take a look at what we know. We know that we're purely horizontal here. So I have no initial y component of the velocity. I have plus 1.20 meters per second for my x based on the way I've drawn it. Remember, standard frame of reference, up and to the right is positive. You don't have to put this notation. I've put it to reinforce it. I know that horizontally I have an acceleration of 0 meters per second squared, which means these two pieces are equal. The final velocity in the x direction will be plus 1.2 meters per second. I know that my vertical displacement from here to the water is minus 10 meters, and then I'm being accelerated down in the y-axis at negative 9.8 meters per second squared. I am going to need to find this y component of the final velocity in order to find the speed overall. So I take a look here, and in order to figure out whether I need any of this stuff, I take a look in y. I have no question marks in x, I have one question mark in y, and then I ask myself, do I have 3 of the 4 variables that I need in this frame of reference in order to find the question mark? And I do. I have v naught, I have s, and I have a, so that means I do not need time in either direction, and I don't need s either in the x direction. So the formula I'm going to use is the node t formula in the y direction, and that is Vfy squared is equal to v naught y squared plus 2a, and the y, recall, is the is the vertical displacement. Alright, so I'm solving for Vf. It's already placed that way, but let's just put my square roots in here to make things nice and clean so I don't forget that piece. Oh, and I should have taken this out because this is 0. So really Vfy is equal to the square root of 2ay. And I'm leaving my subscripts in to make sure that I'm really clear about what I'm doing. Alright, so now I can just plug in Vf of y is equal to the square root of 2 times negative 9.8 times negative 10. Now, if you were doing this and you were left with a negative sign under the radical, it's very possible that you left this as positive as opposed to saying this is my, my ground point, my frame of reference point, and I'm traveling down 10 meters. Or you could have used this as your frame of reference. But again, you recall your displacement is a magnitude and a direction. And so I'm traveling down. So I am changing positions. My final position will be a larger number than my initial position, so this should be negative any way you set it up. All right, so I plug this into my calculator and I get 14 meters per second. I do need to reconcile this though. I am traveling down at this point, so this is negative 14 meters per second is the y component of my final velocity. So then I'm asking, am I done? Well, no, I'm not done. It says speed. And the speed has a vertical component, which we just found, and a horizontal component. So I need to put them back together to get that vector, the magnitude of which will give me the speed. So that's easy. We just do Pythagorean theorem. So Vf is equal to the square root of Vfx squared plus Vfy squared. So Vf is equal to the square root of 1.2 squared plus 14 squared, and I really should put that negative sign in there so I don't forget it. It won't make any difference because the term is squared. Alright, but it's a good habit. And then if you want to do these extra numbers, 1.2 squared plus negative 14, which is squared, gives you the square root of 197.44. And honestly, it doesn't make any difference to me whether you show that. I'm putting it in here just in case you have done it that way so that you can see that step to see if the error was there. And so you should get 14.05 meters per second. Remember, we're not doing any more than 2 decimal places. Truly, if you stick with significant figures, it is 3. So it should have been 14.1 meters per second, and that is the final speed. So I'll write it up here in red. Okay.